Hi everyone, welcome to Recitation 8. Today we'll be going over Module 9, which is Abstract Data Types, and we'll also do a little bit of a review for Exam 3. So to give an overview of the contents of this recitation, we'll start with what are Abstract Data Types, or ADTs. And then we'll start with lists, and that will also cover interfaces, since lists are interfaces. And then we'll cover sets and maps. And then after we cover those three abstract data types, we'll go through object equality, so checking that two objects are equal, and then we'll end with some exam review. So to start, what is an abstract data type? An abstract data type is a data type defined by certain attributes and behaviors. So what this means is that when we're using an abstract data type, we don't really care how behaviors are implemented, just what the abstract data type is able to do. So this means that we might be looking at documentation that just says, like, what are the parameters, I guess what's the method name, and what's the return type. And then once we understand what it does like that, we can use it in our code and get a lot of value out of it without necessarily knowing what's going on behind the scenes. So we don't need to know how the abstract data type is necessarily like storing things exactly, or anything like that. So as an example, to use the string.characterAt method, you only need to know what parameters that method takes and what it returns. You don't need to know, if it's iterating through the string to find the character, if it's what exactly it's doing to find that character at that position. You just need to know kind of how to use it based on what it returns and what you need to give the method. So we've already been using several abstract data types throughout the semester. Like I just mentioned, string is an abstract data type that we've been using since basically day one. Scanner is another abstract data type that we've used a lot this semester. And then zombie and hockey player are abstract data types that have been created for 131 specifically to as part of like the assignments and examples. In general, anytime you create a class, you create an abstract data type, right? Because creating a class is just creating something that is defined by certain attributes and behaviors. And that's exactly what an abstract data type is. So before, when we've been using classes, we've also been using abstract data types. So to start off, the first abstract data type that we'll go over is the list. So list is super common, and it allows you to hold a collection of objects very similar to how an array does. So some things to remember about lists is that they allow duplicate items. They hold items in order with zero-based indexing, which is, again, very similar to what we've seen with an array. As a reminder, zero-based indexing means that the first position is position 0, and it goes 1, 2, 3, etc. One difference between lists and arrays is that lists have flexible sizing. So that means that you can grow and shrink the size of the list as you add or remove items. And this can be really helpful because you don't need to create a new list if you're changing the number of things being stored. Other than that key difference, it's very similar to an array. So should be one of the more straightforward abstract data types to kind of wrap your head around because we've already been introduced to arrays. And then next, lists are what we call a parameterized data type. So we need to tell the list what kind of items it can hold. So this means like if it's strings that are held in the list, or integers, or doubles, or maybe it's a list of another type, like a list of zombies, etc. We need to explicitly state that when we declare, and yes, when we declare the list. So, as an example, let's say we want to declare a list of strings. Here's the syntax for how we would do that. We'd have list, and then in angle brackets, which is the less than symbol, and then the greater than symbol, we would put string as the data type we're storing in the list. And then we'd give our list a name, in this case, words. So like I mentioned, those are angle brackets, and that's kind of what you'll see a lot for these abstract data types. Just as a note, as you're coding, you might get an error that says something like list cannot be resolved to a type. And what that is that's just like an import error with the list abstract data type. So two quick ways to fix this. Either you can hover over the error and when you go to quick fixes, there should be an option that says import list, and that'll just like write it for you and do it for you. Or you can just go ahead and write import java.util.list yourself at the beginning of your file before your class signature. Um, so getting back into what a list is, all lists should be able to add or remove an element. They should be able to determine the length of the list, and they should be able to find the index a certain item is at. So basically, since a list is kind of this collection of things we want to be able to do, a list is actually an interface instead of a class. So far we've been working with classes, but a list is an interface, which means that it's like a collection of method signatures that must be used in any classes that implement that interface. So basically, it's just the user-facing part where it's the methods that you'll have and how to call them. Um, and therefore, all classes that implement list must implement its methods. If you're curious about kind of this interface stuff and want to dive deeper into that, I recommend taking CSE 332, which is Object-Oriented Programming Laboratory. And that goes much deeper into what exactly interfaces are and how to write them, how to write classes that implement them, etc. But continuing on, you can think of the list interface as like the idea of a class. You can't directly create a list because it's just an idea, and there's no concrete implementation of what that list means. It's just basically like the method names and the like idea of what they're supposed to do, as opposed to like a concrete written out way of how that would be like carried out. So we can't initialize an object of the type list, but if we want to create like lists, what we're doing is we're creating objects of the types that implement from list or implement the list. So as you can see in this diagram, the ones that we'll be using are linked list and array list. So with array list and linked list, for this course, you don't need to know the difference between these two, but for other courses, I think it's important to maybe go back and learn that. But all you need to know for 131 is that they implement all the methods in the list interface. So I highly recommend taking CSE 247, Data Structures and Algorithms, if you're interested in these types of like data types and data structures. So we can't initialize a list. We can declare a list, but we can't initialize a list since it's an interface. So therefore, if we want to create a list, we can either say list of string words equals new array list, and then string, or list string words equals new linked list. And you can see there that we have the data type in the angle brackets, but you actually don't need that second string in the array list or linked list part. So because you already have string in the first part where it says list and then string, you can actually choose not to put it in the second part where you say array list string or linked list string. You can just have two empty angle brackets and that will work fine too. And the reason you can do that is because the type can be inferred from the beginning when you say list string. But yeah, this is how you implement, or this is how you initialize a list, is you use array list or linked list. So now that we know how to make lists, let's see an example of how to use one. When we're declaring our list, like I mentioned, we need to know the type of thing it will store. So in this instance, we want to store integers, so we'll use this syntax to initialize an integer list. So we say list, and then in angle brackets, integer, and then we say whatever name we want to give this list, my integers, equals new linked list. And you notice how those are just two empty angle brackets. You don't need to explicitly put the type in there. And then parentheses. So one thing you'll notice is that we say integer instead of just int. So abstract data types can only hold objects, not primitive types. And if you'll remember, int, boolean, double, and char are all primitive types. So what we do is we use a wrapper class, which is a class that holds a primitive type in an object so that it can be used in these abstract data types. So just remember that when you're using integers, booleans, doubles, and chars, it'll be like integer written out, character written out, and with capital letters. So then once we have our list, let's say we want to add the numbers 1 through 10 to the list. So you can iterate in a for loop like you usually would. And to add something to a list, you just use this dot add notation. So we say my integers dot add and then I, and then that will add that integer to our list. Next, let's say we want to print all of those elements in the list that we just added. So we'd want to iterate through the list and print the value at each position. This is going to be slightly different than what we've seen with arrays, because we have, instead of dot length, we have dot size, and note that there are parentheses for size when we didn't originally have parentheses for length for an array. And instead of using like square bracket indexing notation, we use the array's name dot get and then the position to retrieve the value at a certain position in a list. So note these differences between like a list and an array. I know this can be a part that gets a little tricky or just confusing to remember, but just note these differences. And this is because we have to call these methods on the data type instead of just like indexing. So our next data type that we'll go over is sets. So sets are unordered and do not allow duplicates. So a set is a collection of data that is all unique, and you basically won't be able to add a value to a set if it's already contained in that set. Being unordered means that you can't use a for I loop to iterate through a set, and you can't index a set because it doesn't have positions because it's not ordered. But if you wanted to iterate through a set, you could use a for each loop instead of a for I loop, and that's a way that you could still iterate over a set. Within the context of 131 specifically, we only use sets when we're using maps, and then this is kind of how we end up iterating through maps. But sets are really useful in general whenever you have something where you don't want to have duplicate data. So similar to lists, we have an abstract data type called maps. Maps are collections of key value pairs, so there's also no ordering, similar to a set. Because there's no ordering, there's then no indexing and no iterating with a for I loop, but you can still use a for each loop. So here is an example where we might want to map the key, which would be like a person's name, to a value, which would be their favorite color. So you notice that the keys are all unique. You have, 5 different names, but you can have repeated values for the value, the favorite color. Just like list, map is an interface. So map itself is not like something you can make an instance of. It's an interface that is implemented by HashMap. So here you can see the syntax similar to what we discussed with lists, where you start by saying map, and then you put in what data types you're storing in your map. The first one represents the data type of the key, and the second one represents the data type of the value. So in this case, it's string, string. You name your map, favorite colors, and then you say equals new hash map, which creates that actual instance using the hash map class that implements the map class. So to add key value pairs to a map, we use put. So kind of similar to how we said dot add for lists, for maps we'll be using put, so dot put. The parameters for this are the key and then the value. So in this example, let's say we want to add Ollie to the the map and we want to put his favorite color as green. We would say favorite colors dot put Ollie as the first parameter and then green as the second parameter. Like I mentioned before, there's no indexing in maps, but to like quote unquote look up a value in the map, what you do is you use the key to find the value. We can use this get method where you say, like in this example, favorite colors dot get, and then you provide the key in the parentheses whose value you want to find. So in this example, if we say favorite colors dot get and then put Dorian in as the parameter, we can expect this to return blue, since blue is the value associated with the key Dorian. And then, similar to sets, maps are unordered, so you have to iterate over all the keys. So if you look at this chunk of code, we have our map, favorite colors, which has string keys and string values. And then we can create a set out of the keys. So, like I mentioned, keys are unique. You can't have the same key. So that's perfect for a set because you can't have duplicate values in a set either. So say set and then of string, because strings are the data types of the key, as we can see in favorite colors. Then you can make a set out of the key set from the map. So you can use this favorite colors.keyset method to get a set of the keys. And then you can use a for each loop, like I talked about with the set data type, to iterate through all of the keys in that set. So this is what the set might look like. It would say Ollie, Dorian, Ethan, Margaret, Abby. But remember, a set is unordered, so it wouldn't necessarily be in that order. But it would iterate over that collection or that set because those are the keys from our map. So to wrap up and give an overview of maps, maps are unordered. They do not allow duplicate keys. And if you try to put in a value with a key that has already been used, all it will do is override the old value. So that's something to kind of watch out for. And then to add something to a map, you use put. So you say your map's name dot put. If you want to get the value for a certain key, use get. You cannot directly iterate with a map because there's the keys and the values. So you can iterate over the key set or the value set. So when working with abstract data types, being able to read documentation is really important. On exams, we'll provide documentation for methods that we think you'll need or may want on the exam, but you'll need to know how to interpret that documentation. So I might practice reading documentation from like Java, like online documentation for Java as a whole, or you could also practice reading documentation for like the standard draw library. But in general, honestly, not even just for abstract data types, but in general, being able to read documentation is really important, but it will be important for this exam. So, as an example, let's say I want an integer with the same value as my int variable. How can I use the value of method to do this? And then let's say that this text at the bottom of the slide is like the documentation, because this is what the documentation might look like. You need to know kind of how to interpret this, like the return type, the method name and parameters, and description, and then you should be able to know how to use this method. So in this case, we would call the value of method, we would put the integer I that we're trying to find or we're trying to like, I guess, convert to an integer in as the parameter. And then we would get back the integer that has the same value as our int. So this is what it might look like in code. You could say integer.value of, and then put your integer, or you put your int x in as the parameter for this method. And then integer.value of x would return an integer, like that wrapper object, with the same value as your original int x. Here's another example. Let's say I want to check whether a key is already in my map of integers and booleans. If the key is already in the map, I don't want to do anything. Otherwise, I want to add the key to my map and set its value to false. So we can look at this documentation here, and I'll actually give you a couple seconds to kind of think about it for yourselves, and then we'll come back in a second. Okay, so we're looking at the method put if absent, and we can see from the method name and parameters that this is called put if absent, and the parameters it takes are the key and the value. What it does, it says if the specified key is not already associated with a value or it is mapped to null, it associates it with the given value and returns null. Otherwise, it returns the current value. So now we know what's the expected behavior of this method. So how do we actually use it? Let's say we have this map, M, which has integer, keys, and Boolean values. Let's say we fill M with some values. Just pretend we did that. Then we can call m.putIfAbsent 5 false. What this does is it checks if 5 is already a key in the map, and if it is, then it returns the value that was originally associated with that key, and it doesn't do anything to the map. If it wasn't already associated with the value in the map, what it'll do is put that key and value into the map. So this is how we'd use it. Hopefully that makes sense based on the documentation. So now we're going to give you a map example to work out on your own. So we want to make a method that takes two integers, n and m, as its parameters. Your method should return a map with the keys 2 through n inclusive. Each value should be the number of times its key was divisible by m. So if n was 40, your map would be filled with numbers 2 through 40. If m was 2, then key 2 should have value 1, key 4 should have value 2, key 8 should have value 3, etc. So pause this, try it on your own, see if you can figure out how you would implement this, and then we'll come back. Okay, going to switch the slide. So we have our mystery method here. You don't have to call your method mystery, but so public static, and then we're returning a map with integer keys and integer values. The method's called mystery, and it takes in parameters n and m. So we start by initializing a new map. So we say map, and then we give integer for the type of the key and the type of the value. We can name it result, and then new hash map. So we can iterate through from 2 to n, and what we'll do at each one of those values is we can set times divisible to be 0 because we want to start from 0. We can make a temporary j, which will just take in the value of j so that we can modify it and do some things to it and not mess up our for loop. And then while temp j is divided by m has a remainder of 0, so that means we use a modulo operator to know that temp j is divisible or evenly divisible by m. While that is true, we add 1 to times divisible, and then we divide temp j by m. So what this will do is just iterate until j is no longer divisible by m, and we'll add on those values to get a number for how many times j is divisible by m. Once we find that value, then we put into our hash map the key, which is the integer dot value of I. So remember, we have to convert I to be an integer, capital I, instead of just an int. That's because the hash map can only take in objects. And then, so that'll be the key. And then for the value, we do the same thing where we say integer.value of, and we take that times divisible number. So then do that iteration, and at the end, you'll have that result.
All right, so we already went over this a little bit in some of the previous modules, but always good to review object equality, especially with maps and sets which don't allow duplicate objects. So the principal difference is between double equal sign for telling whether things are equal and the dot equals method. So, like we talked about in, I believe, module 7 and 8, the double equal sign will compare the objects themselves. So abstract data types are stored as what we call a reference variable. And so when you're calling the constructor of, like, let's say the student type, we would be making a new student object, which, if you're not familiar with the student class, go ahead and review assignment 7, but you don't need to know like the specific details of the student class to do this exam to follow this example. But yeah, and so when we call the constructor, we make a new student, right? And then in that actual variable spots, let's say S1, inside that variable, we're just storing the reference for that new object. And the reference is just where in your computer the actual like information for that object is stored. And so double equal sign is just comparing that reference or the location within your computer. So just the identity of the objects themselves. Was it like the exact same time that we called the constructor? And then the dot equals methods is going to actually compare the attributes of the objects to see whether the attributes are the same. So usually like name or I mean in the student class I like to use like ID because everyone has a unique ID, but two students could have like the same name or something. But um, either way, the equals class should compare some information that would be like very specific to that object. So only that object would have like the same versions of those attributes. So for this example, let's assume all students have their own separate name. So we're making student S1 equals new student with name Abby, and then student S2 new student with the name Dorian. So we can see clearly these students have different values for the name, right? And we called the constructor two different times, one for S1 and one for S2. So they are definitely stored in different places in the computer's memory because we called the constructor two different times, and they have a different name. So the dot equals method is of course going to give false. So, and then, well, let's say we make two different students, right? We're calling the constructor twice, but they both have the exact same name and assume like all their other information's the same. Well, we call the constructor twice, right? And but each time we're calling the constructor, we're creating a brand new object in your computer's memory. So, S1 and S2 will be stored in different locations in your computer's memory, which means that S1 double equal signs S2 is going to return false. Because you call the constructor two different times, they're in different parts in your computer's memory, not the same object. It doesn't matter if all the information is the same. Meanwhile, if we do S1 dot equals S2, well, assuming the only criteria in the equals method is their names, we know they both have the same name. And so they have the same name, and so they're considered the same object by the dot equals method. And whenever you're making your own abstract data types, you can define the equals method. For your class, you just have to make sure it follows the like exact method signature of the equals method. But yeah, you can define your own version of the equals method. We didn't provide one here, so we're just gonna assume that this equal method only depends on the name, and since they have the same name, the s1 dot equals s2 will be true. But what about in this third example? So student s1 equals new student with the name Abby, and then student s2 equals s1. Well, I only called the constructor when I was creating the S1 variable, right? So S1 for this first line, I made a new student. It's stored somewhere in my computer, and S1 stores its location. Then, when S2 is being set equal to S1, well, S2 is now going to refer to the same location as S1. So in these double equal signs, well, S1 and S2, like I just said, they refer to the same location, so that's going to return true. And I mean, obviously, they're the same object, they're in the exact same location, and like comparing the name of the student in the exact same location, like that's of course going to be true because it's comparing the same object. It would be the same thing if we did S1 that equals S1 because both S1 and S2 are referring to the same location. So S1 dot X2 dot equals S2 is definitely going to give us true as well. All right, and then now for just a quick cheat sheet to refer for stuff related to object equality. So if we have two objects, O1 and O2, doesn't matter what their type is, If O1 double equal signs O2 is true, then O1 dot equals O2 must be true. And that's because we really only have one object. O2 in this case would just be like pointing to O1. So it would be like like this example. So we'd be creating a new student object only once, right? We're only calling the constructor once, and then we're setting S2 equal to S1. So the object that we already constructed. And we're not calling this constructor again. It's not making a new object. It's just making it so that S2 refers to the object created in the previous line. So yeah, they're really both pointing to the same object. And so when we say O1 dot equals O2, we're comparing the same object to itself. And so it's definitely going to be true. But if we call O1 dot equals O2, it's possible that O1 double equals sign O2 is false. Because the equals method just tells us that the attributes are the same, so maybe they have the same name, or like the same ID or something. But if we don't have two exactly identical objects, double equal signs would return false. So that like in this case would be like this situation. We create two objects, they have the same name, but we call the constructor two different times. And so double equal sign will be false because call the constructor two different times. The variables refer to a different location in your computer's memory, but they have the same name, so s1 dot equals s2 would be true. All right, and now for some good old ADT practice. So, if you did assignment 3, you will recognize the bubble sort method. And so, for one type of practice you could do, you could implement a method for bubble sort instead of just like writing bubble sort in main. And so, your method for bubble sort would take a list as a parameter, and then would return the sorted list. And presumably be a list of integers. And then, or you could do doubles, it doesn't really matter. And then check the assignment's 3 instructions for more info on bubble sort. And then if you've already done bubble sort, try insertion sort instead. In the slides, I'll put like a little note for this slide with some instructions about insertion sort, but it's fairly similar, just a different sorting method. All right. And then alternatively, if you want to practice maps on your own, you could choose your quote, maybe a favorite quote, and then make a map that uses each unique word as the key and the number of letters as a value. So relatively straightforward. Um, and then if you want to like practice iterating through the values in a, or keys in a map, you could iterate through the keys or the key set, which we talked about earlier, and then print every key whose value is at least 5. So none of the short words. Just the ones whose length is 5, or you could choose a different number. Doesn't matter. Cool. And then now for exam 3 review. Overall, we're not going to cover module 9 again because we just did that, but a little review of 7 and 8. And some of these slides are going to be like the same from the previous recitation, and we definitely recommend that you watch the recitation for Module 7 and 8 because it goes through the topics in a lot more detail. This is just the important stuff from Modules 7 and 8, and we have some extra examples that weren't in the previous recitation. So, for some vocab, object is an instance of a class. So you can use them more or less interchangeably. So an instance is one specific occurrence of a class, so we make an instance whenever we call the constructor. A class, it's just the blueprint on what an object is, like what information it has, and how the object behaves. What can the object do? The constructor is a special method that creates an object. The constructor doesn't have a return type because its job is to create the object. And one of the most important jobs of the constructor is to make sure that all the instance variables for that object have a good starting value. And like not all the instance variables are going to be within the parameters for the constructor, just the ones that like are most relevant for like making a new instance of that class. Um, you can see an example of that in a second. And then static, if it's a static method or a static variable, it means it belongs to the class rather than an object. So non-static, it belongs to a specific instance of the class. Static means it belongs to the overall class. And then instance variable, it's an attribute that belongs specifically to an object. Access tells who is allowed to view or call the variable or method. Um, and then the only options we learned for this class are private, which means only can be used within this class. Um, and then public, which means it can be used in other classes, many classes at once. And then we have good old encapsulation, so capturing related data and behaviors into an object. So, let's say this is using the person class example from the previous recitation. Um, but basically we have whenever we're making an object, we have first the type of the class, in this case person, then the name of the object can be whatever you want. Um, be creative with it. So Dorian in this case, and then equals new. You have to use the new keyword to tell Java that hey, we're taking a chunk of the computer's memory. We need to set that aside for making a new object. And then person is the type slash name of the class. That's where we're calling the constructor. And then inside these parentheses will be any parameters the constructors take. Sometimes the constructor doesn't take any parameters, but a decent amount of the time it does. So here you can see an example with the person class. Cool. And then a very important keyword we have for classes is this. So let's take the Dorian object from the last slide. So when we call a method on Dorian, so when we call like the introduce method on Dorian, this is referring to Dorian. So in just a broader context, this refers to the object that you called a non-static method on. Because, like we talked about earlier, non-static methods have to be called on a specific instance. And non-static methods can, and most of the time need to, use different instance variables for that specific instance. And so we need a way to be able to actually refer to specifically the instance variables of our instance, right? And so this just specifies that we're talking about the instance variable for this, for the instance of person that this method was called on. And so just to, yeah, I like the phrasing of like a nickname for whatever the object the method was called on. So in this introduce method, we use this dot refer first name to represent, hey, we're getting the first name specifically of the object the introduce method was called on, which in this case would be replaced with Dorian because we called it on Dorian. Um, and then one of the situations when you definitely need to use this is, let's say you have a method and a parameter has the same name as one of your instance variables. Well, within the method, like let's say the parameter's name was, I don't know, name, right? Um, well, if since the parameter and the instance variable have the same name, the Java will see, oh, the parameter was made most recently. And so anytime you write just like name, Java is going to assume that you're referring to the parameter. So you have to write this dot first name to specify, oh, I want to talk about the instance variable, not the parameter. Um, Plus, like I think putting this in front, like this dot first name, even if you don't have like a parameter to worry about, I think it's useful just to make sure that like you know exactly what information you're referring to. So, just a quick overview of this. And then that's just our quick overview of classes. If you want more information specifically on stuff like encapsulation, go to the previous recitation. But here's a new silly example of classes. So let's say I work for the Gateway Arch National Park, St. Louis reference. And then I want to make a class to keep track of all the trees on the park because I had to make sure they're all doing well. Well, trees have an age, a height, a number of leaves, which I don't know who's counting all those leaves, but it's just an example. And then it has a like location in the park. I'm going to represent that as longitude and latitude, and it would be pretty hard to represent longitude and latitude as like a double or int or anything. It wouldn't really make sense. So I'm just going to store that as a string. And then trees can grow or get older or get replanted, move to a new location. So, with this ideas, I don't have like there's not like super specific requirements for any of these attributes or methods. So you can kind of interpret this as you want. Just good practice getting like designing things on your own. So, try implementing the tree class on your own, and I'll show my interpretation. But if like you have a different implementation of some of these methods, as long as it makes sense for you and it works, feel free to like do it your way. And like on an exam, we'd give you like the specific requirements. You can do stuff like differently as long as it meets those specific requirements. Like an exam would tell you like what return type you should have, what parameters you should have, what instance variables you should have, etc. But like if the exam If the exam doesn't tell you that you can't have extra instance variables, then you're free to have extra instance variables or something like that. All right, so that's a lot, but that's some yapping. But try implementing the tree class. I'll give you a few seconds to pause, and then I'll go into my example. So, 3, 2, 1. All right, and so now for this example of an implementation of the tree class. So I have my class declaration up at the top, public class tree. And then I'm putting all of the instance variables. So private double height, private int age, etc. Just gotta like declare those, make sure they're all private so that other classes can't access and change them willy-nilly. Um, and then we have our public tree constructor. And it's just taking two parameters, longitude and latitude. And that's because, like for the other instance variables, like height, age, num leaves, there's a pretty logical starting value. Like we're assuming this tree was just planted. And so it doesn't have a height. It hasn't grown yet. And similarly, it is 0. It just got planted for its age. And then num leaves, it just got planted. It doesn't have any leaves yet. So all those make sense to put at 0. And then the longitude and latitude, there's not really a good default value for that. Like it has to have been planted somewhere. And so just setting those based on parameters makes the most sense. And then I labeled it as constructor down here because I didn't have space. But yeah. Um, Hopefully that makes sense, but it's totally chill if your instance variables are a little different or something like that. And then you'll also notice I didn't put this dot num leaves equals 0. And that's totally okay because it's not like there's a parameter or anything that's named num leaves. So I can just write num leaves equals 0, but for like longitude and latitude, well, there's parameters named longitude and latitude. So I'd have to do this dot longitude to specify that I want to store the parameter longitude inside of the instance variable longitude. All right, and then here's a couple of the methods. I don't show all like the getters and setters in here. I show a couple just so like you can see some, but yeah. All right. And then, so for this first one, grow, just height grown, leaves grown, just increasing the like amount that the height has grown and the amount that the leaves have grown. Again, I don't technically don't have to put this dot height here. Um, it's good to just specify if you want to, just like make X, like really reinforce that you're referring to the height instance variable, but you don't have to. All right. And then here, it with like the slash and the two asterisks, this is what we call like a Java doc comment, which technically I should be providing these for all these methods. I don't have that much space on the slide, so I'm not going to. But yeah, these are good to have in front of all your methods. You can skip them for getters and setters because they're pretty straightforward, but um, good to have for all your methods. And so first you have just a quick description of the method. So it's called get older, which maybe I should have named it grow older or something, but just a description of the method. It increases the tree's age. And so param age increases the amount the tree's age has increased by in years. Maybe it would be good to add that we're assuming this is a positive number and that no one is trying to de-age our tree, but something you could consider on your own if you want to make this like class a little more robust. And then at return tells you the return value. So we're returning the tree's new age because people might want to know what the tree's new age will be after the age increase. So hopefully that's pretty straightforward. Let us know if you have any questions on that. And then for the get replanted method, well, we gotta have our new latitude and our new longitude. And then we're just setting it equal to. And again, we don't need the this because the parameter and the instance variable have a different name. I'm sure there's a different way you could do like modify this method by like just having like maybe change in latitude or change in longitude. And I realize I switched the order, but that also doesn't really matter. Um, yeah. Um, yeah, I don't think I have any other notes to put for this one. I'm sure you could implement it a different way. Could be a little trickier though. Cool. And then here's one example of a getter. So it's just get height and then return height. As you can see later, we'll probably need more instance variables for our just like general tree class. So, in your like I said, your tree class might look a little different, but that's okay. As long as your design makes sense for you, and especially if you have like Java comments explaining what each method and like a little explanation about what each instance variable represents, you're totally good. Implement it how you want. Just this example is just supposed to give you some practice with how you can implement a class. And then on the exam, the like basic requirements for a class will be given for you, like what instance variables you need, what like return type the method should have, what parameters the method should have. And then if any piece of information isn't specified, you can choose what you want. And like as long as something like, oh, you can't add any extra methods or you can't add extra instance variables. As long as it doesn't say something like that, you can add an extra method or an extra instance variable. That's totally fine. All right, cool. Then let us know if you have any questions on that. Now, just a quick review of Module 8, Inheritance. So, overall, inheritance is just the idea that one class, called the subclass, can inherit methods and instance variables from another class, which we call the superclass. And this creates a relationship. So, like I was saying earlier, a tree has a number of leaves. And that's different from an is a relationship. It's like, let's say hockey player was, maybe we can make hockey player a subclass of an athlete class. So then we would say hockey player is an athlete, a dog, let's say that's a subclass for the animal superclass. Well, a dog is an animal. And then if you've done module, or if you've done assignment 8, a zombie is an entity. And then there's some different terminology. We use superclass and subclass. Some people call it the parent class and the child class, though. So parent class is the same thing as superclass, and child class is the same thing as subclass. And so whenever a class inherits from another class, we say it extends that class. And that's the word you would actually use in the class signature, um, or class declaration to like indicate that it's an inheritance relationship. So for the hockey player example, I do public class hockey player extends athlete. And then super is the keyword we use to access method. And if there's public instance variables, realistically, you're not going to have any for this class at least. But it's super is the keyword we use to access methods and other public instance variables from the base class. So if you are going to call the super constructor, you would just do super, and then you'd include between the parentheses any parameters that the super constructor takes. And you have to call the super constructor within each constructor for the subclass. And then in the subclass, if you're trying to access methods from the superclass, you would just do super dot method name, and that would give you the version that's in the method class instead of the version or the version that's in the superclass, not the version that's in the subclass. And then again, if you're trying to access public instance variables or protected instance variables, we don't talk about protected, but if you want to look into that on your own, feel free. But yeah, for accessing public or protected instance variables, it would be super dot variable name. And then overridden methods, very cool stuff. They're just methods in the subclass with the exact same signature as the method in the superclass. And what that means is the subclass method has to have the same return type, the same name, and the same parameters as the method in the superclass. And that just allows methods in the subclass to have a different functionality. And we'll get into that in our next example. So, and then now we have, I don't know why I paused. Okay. All right. And so now we have polymorphism. So we can just break down polymorphism into two parts. So poly kind of means many, and morphism kind of means forms. And so this is using the movie example from Recitation 8. If you aren't familiar with that, just go back to Recitation 8 and watch that a bit, but you don't really need to know any of like the specific methods in the movie or comedy movie class for this. But let's say we declare movie Scott Pilgrim and it equals new comedy movie and pretend we have all the parameters for comedy movie here. Well, does this line work? I mean, we have comedy movie and it's declared it extends the movie class, right? And so we can think of all comedy movies are going to be within this movies class, right? Because a comedy movie is a movie. And so this line will work because the even though the actual type of this variable is going to be a comedy movie, well, comedy movie falls within the movie category, and so we can store it as a movie. A movie would be the declared type or the compiler type. Whereas comedy movie, we call it like the actual type because it's the constructor we called. And you can also call it the runtime type. But let's say we tried to do it the other way around. Comedy movie Scott Pilgrim equals new movie and the parameters that the movie class takes. Well, not all movies are comedy movies. And like the movie category, we can think of it as way more broad than the comedy movie category. So we can't put something that's more broad into a narrower category. That just doesn't make sense. So we can say new like movie Scott Pilgrim equals new comedy movie, but we can't say comedy movie Scott Pilgrim equals new movie. So you can store a like you can declare an object of the subclass and store it in the superclass in a variable of the superclass, but you can't like initialize an object in the superclass and store it in the like declare type of the subclass. Cool. And so let's say I want to represent a different type of tree. So how might I make an oak tree class that extends the tree class? Well, all oak trees have all the regular properties of a tree, and then a number of acorns, because not all trees have acorns, but I believe all oak trees do. And then they have a leaf color, because oak trees can change color, and not all trees can change color. And then a number of rings, because not all trees have rings on the inside. Fun fact. Um, and then oak trees can grow or drop acorns. I'm gonna make this one method. It would probably be better if you made them different methods, so feel free, but I'm just trying to save space. And then oak trees, at least most oak trees can lose leaves. Some are evergreen, but I'm gonna just for say it's not an evergreen tree for this oak tree class. And then most oak trees change leaf color, and then also when they age, they add a ring. And so we want to override the age method so that when the oak tree ages, it also adds a ring. So go ahead and try writing this class on your own. Feel free to add extra properties or methods if you want. Just try and like include this basic stuff, and then we'll go over an example implementation in just a sec. All right, and so now we're getting into our specific implementation of the oak tree class. So note we have public class oak tree and that it extends tree. So that's how we indicate that it's an inheritance relationship. And so now we also add our instance variables that are specific for oak trees. So int num rings, int num acorns, and color leaf color. You don't need to worry about the specifics of the color class. I mean, if you want more information, just like search Java documentation color. But it's just like a convenient way of representing color. Cool. And then yeah, of course, make sure instance variables are private. Um, because we don't want other classes to be able to change the number of rings our tree has, or well, our oak tree has. And so now we have public oak tree, and then it happens to have the same parameters as the superclass. But if you would like it to have different parameters, feel free. Um, and like it's not like the constructor for the subclass has to have the exact same parameters as the superclass. But, and then inside, I like to make it the first thing you do in a constructor for a subclass. We call the super constructor for the superclass. So you just write the word super, and then you have to have the same parameters here that the super class's constructor takes. And so it takes longitude, then latitude, so we just put that here. And I think I switched longitude and latitude, but okay. Or like I don't know why I put it in this direction, but this is the way that the tree class took it. So yeah. And then I'm setting and so when we call the super constructor, it does all the stuff that the super constructor does, right? So it sets like the age, the number of leaves, height, all that good stuff. And it also sets the longitude and latitude to the values we passed in the super constructor. So super constructor, calling it, it sets up like the oak tree as a tree, so it can be recognized as a tree. And then all we have to do in this constructor is just set the instance variables that are specific to an oak tree. So number of rings. We're assuming this tree was just planted, so it doesn't have any rings yet. Similarly, it just got planted. This tree doesn't have any acorns. And then I just put like a default leaf color to be green, um, which I don't think oak trees ever have that specific shade of green. But color.green, green is with all caps is just a static um, and final instance variable in the color class. All right, and then public void set leaf color with a new leaf color. You can change the leaf color. Can probably make this method a little more unique, but just a simple setter. All right, and so for the first example on this slide, we're showing an example of overriding a method from the superclass. So for this example, you'll notice it has the exact same parameter or method signature as the version in the superclass. So the return type is int, the name is get older, and the parameter is int and int. We could name age increase something different if we wanted to. I just didn't want to. All right, and so we're calling the get older method from the superclass by doing super dot get older. Um, and so we still have to provide the same parameter that the superclass expects for the get older method, which of course is just int for age increase. And then we want to increase the number of rings that our oak tree has by age increase, which I mean, it's kind of silly that we're storing the number of rings separately from the age, since the number, like each ring indicates 1 year in a tree's growth, but it was just like an easy example you could think of for overriding one of the methods in tree. All right. And then, so for grow or drop acorns, again, you might want to split this into like two separate methods, like one for grow acorns or one for drop acorns, but I just decided to make it one method to save space. So it's going to return an int, which represents the new number of acorns, and then it takes an int as the parameter, and that's the change in acorns. So if it's a negative, if change in acorns is a negative number, meaning that means like I dropped acorns. So it prints dropped, and then the absolute value of change in acorns. And feel free to look up the documentation if you want to see the documentation on math.apps, but it just takes the absolute value. And then num acorns adds the change in acorns. And it's just a negative number, so um, like adding a negative number is the same as subtracting um a positive number, but yeah, we're just decreasing the change in acorns. And so in this else, well, it was a positive number or at least zero. You could maybe make it so like add like an else if so that if change in acorns was equal to zero, like it just says didn't grow any acorns or something like that. But I just wanted to save space, and it's like not that weird to say it grew 0 acorns. So, but yeah, in this else, it was at least zero or a positive number. So it prints grew, change in acorns, and then num acorns increases by change in acorns, and then just return number of acorns so that whoever called this method now knows how many total acorns there are. All right. And then just one last quick example. Again, I don't provide all the methods that might be useful for this class, just so we don't have to spend a ton of time. But feel free to add like additional getters and setters, all that good stuff. Like, because for instance, the num leaves instance variable is in the tree class, right? And I didn't like write out a getter for this, or a setter for this just because it's like pretty straightforward. But try writing it on your own. And like the thing is, so since the numLeaves method is in the super or some numLeaves instance variable is in the superclass, we can't access it directly in the subclass, but we can access it through getters and setters. So we can, for this if statement to see if like we're losing all our leaves, we can use our getter to check if the number of leaves is equal to zero. And if it is equal to zero, well, it's not like we can lose our leaves. There's no more leaves to lose, so we return false. And then otherwise, if we have more than zero leaves, we would just set the number of leaves equal to zero and then return true because we were able to lose the leaves of our oak tree. So yeah, again, totally okay for yours to be different. And if you want to add some additional things, like more getters and setters would be good. Or if you want to make any of these methods a little more robust, you can also add some like static instance variables. So maybe an oak tree could have a like instance variables for its species. Um, or it could have like an instance variable for like the maximum height that an oak tree can get to. Or you could add like additional like properties or behaviors for an oak tree, or a tree. I don't know that much about trees, but if you know more things about trees, they're like, hey, a tree or oak tree should be able to do this. Like I don't know, house certain insects or something. And then you could also make a new type of tree, or a more specific type of oak tree. I know there's a lot of other variations of oak tree, but yeah, could try making a new class that extends either tree or oak tree, and try making that. So hopefully that example makes sense. Let us know if you have any questions. And then here's some general code writing tips. So for objects, it's helpful to identify the instance variables and behaviors. So instance variables, that's just the information that an object should have, and then behaviors, what should an object be able to do? And so instance variables or IVs, let's say has a relationship, like an oak tree has a number of acorns. Meanwhile, inheritance is a relationship, so an oak tree is a tree. And then all instance variables should be initialized in the constructor, but not all the instance variables need to be taken in as parameters in the instructor. One common example is if we have like a list as an instance variable, we don't need to take in any parameters because more often than not, like there's not going to be a list that we already have. Like there's not going to be an already constructed list that we would assign our instance variable to. So we wouldn't necessarily have the list as an instance variable, or we would not if we have a list as an instance variable, we wouldn't necessarily have a list as a parameter. We would just like initialize the list in the constructor and just make that an empty list because throughout the rest of the object's lifetime, we'll be like adding or changing all the stuff that should be in the list. And then instance variables should always be private. Methods, for the most part, should be public. If there's like a helper method within your class, you can make that private. Like, honestly, if like another class should never access the method in like your class, then you can make it private. But in general, most of your methods are going to be public. All right, and then inheritance. Already talked about that how that is a relationship, and so it's and like so your subclass is going to be inheriting data and behaviors or instance variables and methods from your superclass. And so when you're making your inheritance relationship, identify what behavior and attributes are different between the base class and the subclass, um, or the superclass and the subclass. So for the previous example, all trees have leaves or I guess needles if it's a evergreen tree. Um, so yeah, that's why like the num leaves instance variable was in the tree class, but not all trees have acorns, so that's why the acorns instance variable was in the oak tree class. And so another way to like phrase that, what can the subclass or the class that extends the base class do that the base class, aka superclass, can't? And then remember to call the superconstructor in the constructor for your subclass. You have to do this. And then call super methods when necessary. Not required. You would just do super dot name of the method to access the method from the superclass. It's very useful if you're overriding a method. Or if you're using like the previous, like if you're overriding a method and you want to use like the version of the method that's in the superclass. So you would call like super dot like get older as in the previous example. Um, but then you could like do additional stuff like increase the number of rings. All right, and then abstract data types. Always good to identify which abstract data type you need for like that situation. So, do you want ordered data where the size can change? Then you would probably want a list. I mean, you could use an array. Well, an array isn't an abstract data type, but if you don't need the size to change, go ahead and use an array. But if you need the size to change, it is much more convenient to use a list. Or do you need unordered data where the size can change? Well, that's totally good for a set. And I'd also say note for a set that you can't have duplicates in your set since it's unordered. So if you need unordered data and you don't want duplicates and you want the size to change, go ahead and use a set. And then do you need a data that's like associated with each other? So a key value pair. Like you don't need indices, but you need like a key to be associated with a value, then you should use a map. And then remember what each abstract data type can and can't do, and also like what you actually like what constructors you need to call for each of these. Like list, you can call either array list or linked list constructors. Set, if you ever make a set, you could use the hash set constructor. Usually you don't have to do that for this class. And then map, you'd be calling the hash map constructor. Cool. All right, and then hopefully that was a helpful review. Of course, come to office hours or just ask us if you have any questions. And this is our final recitation. So sad. We'll miss seeing, well, making videos for y'all. And then next week's lecture. So oh, I don't know what day of the week that is. But Monday before Thanksgiving break. That lecture is basically bonus office hours with the professors. I think they'll have some content prepared, but it's mostly gonna be like review and no new stuff that's gonna be on the exam. Like I think they're considering talking about like ChatGPT and AI guidelines. So yeah, no new content that's required for the exam. TLDR. And then quiz 9 isn't going to be until December 1st. So if you have Thanksgiving plans, make sure that you're back by December 1st, but you could there's nothing stopping you from like leaving on Monday. Because like there's no new content that's going to be on the exam. I'd recommend it. It'll be good. It's always good to start studying for the exam early. And ask questions if you have any. But yeah. All right. And then last day of TA office hours will be Wednesday, December 3rd. And then exam 3 will be on Thursday, December 4th from 6:30 to 8:30 p.m. Check the exam review page on Canvas for all the requirements for the exam, and like your room number. And then the final exam will be December 12th from 3:30 to 5:30 p.m. And so we'll definitely grade exam 3 before the final so you can decide whether you want to take the final because you do get one exam drop. And then we don't for the final exam, not as many people take it, and so we're only gonna have one room number more than likely. We haven't decided the room number yet though, so check Canvas before the final to see what the room number will be. We don't have any information on that unfortunately. Um, and then yeah, of course, always check Canvas for like the specific requirements for what you're allowed to bring to the exam and such. And then yeah, should be all the upcoming updates we have for y'all. But thank you all so much for a great semester and for watching all these recitations. We really appreciate it. Hope that these recitations were helpful for y'all. And yeah, just thank you. Y'all are a very important part of this course. And so yeah, good luck on everything that's upcoming. And thank you again for watching. Bye bye. Um, and if you celebrate Thanksgiving, happy Thanksgiving. If not, happy 3 days off of classes. So, bye.